All right. Welcome to episode 59 of the Infrastructure Matters podcast, a podcast in which we count episode numbers because we're all pretty much geeks. Welcome back. I have with me my good friends and colleagues, Steven Dickens, Dion Hinchcliffe, and Camberley Bates. Folks, this is the season, right? We're all somewhere. I think I'm the only one that's not somewhere this week because I tapped out. I have to tell you, I started the week off and I was supposed to go to HashiConf and I just didn't. I did not go. So to my friends at HashiCorp, I'll see you next time. But everyone has been somewhere, and we have a lot of news to get to. So let's get to it. And Dion, we're going to start with you because you were at I think analyst events are special, but you're at a special analyst event for IBM. Talk to us about it.
Well, the setting was New York City, and they brought people from all over the world. IBM's really on an upswing. Their CEO the last couple of years, Arvind Krishna, has done an outstanding job, kind of making IBM relevant in the enterprise again. Really reclaiming, the lost glory what they had with AI. They used to be an AI leader, as you remember, with Watson. And they really want to reclaim that space, and they want to be the enterprise AI company. And they had lots of things on show, including large language models. Their Granite large language model can perform as well as all the well-known large language models, but at a fraction of the cost. And AI is expensive, and so this is their value proposition, saying you may not have heard of it. Granite may not be famous. But it's going to work for you because it's very inexpensive to run compared to all the other ones. So they had some very compelling models, and Arvind was very impressive himself. He said, I sat an hour to come in front of the analysts. There was no slides. He spoke extemporaneously. It was an ask me anything, so analysts could ask him anything for an hour, and we did. Our CEO Daniel Newman got a good one in. And he really defended the company and how they are coming back, and they're resurging, and the stock price has been doing well. So they had lots of announcements, which are all under embargo, and I can't tell you about them yet. We can tip the hat next week on Infrastructure Matters. But I can tell you they're mostly around AI and the things that they're doing. But they did give a big update on quantum. IBM is convinced that quantum's about to hit our data centers and be coupled, just like GPUs are coupled with CPUs. They showed their Heron chip with 156 qubits. It's just about ready to go into the data centers. And 156 qubits is, especially when chained together with multiple Heron chips, is enough to get real work done. Before, the quantum computers were really just toys. They could just simple basic algorithms really, really fast, of course. But IBM's really demonstrated their lead in quantum. The Heron chip is very impressive, very low noise, very high accuracy compared to previous generations of quantum. And so I'm actually I was pretty sure we're not going to see quantum for at least another 5 to 8 years. We're going to see it in the data center, in 2 to 3. It's pretty interesting. So,
Dion, that is very impactful because for a couple different reasons. One, the number one place that technology goes before it hits the public is nefarious applications. So
yes,
it's either porn or it's cybersecurity. Honestly, that's where we see like the videos, DVDs, all that kind of stuff. That's where that went first. And when we were at Lenovo Tech World, we had their Doug. I can't remember his last name.
Yes, we spoke to him for about an hour. Yeah, fascinating
stuff. And the big thing they're talking about is, okay, so, big thing. Here's the date that the government is saying we have to have quantum, encryption capabilities, et cetera. And if this is coming online now, we're missing that date. Because I think you said 2030, you had to have the implementation, and if that's true, we are behind what we need to do for cybersecurity.
There was news this week.
They've been talking about quantum safe encryption for 4 or 5 years. So IBM's been, maybe they knew that they were going to be out first with quantum from a technology point of view, but I think it was Yeah, it's 4 years ago that IBM started talking about quantum safe encryption.
That's a big deal.
And the Chinese announced that they've broken part of RSA using the D-Wave quantum computers this week. That was the other big news. So we're now entering this where we, making quantum safe. That was one of the big messages that IBM had, is for that exact reason, is that the e-commerce on the internet, cryptocurrency, and a whole bunch of other things that we do private public key signing with are all at risk with these quantum chips. And so it's going to be, if CIOs are on notice, that we got to start dealing with this right now.
Wow.
Yeah, there's 4 new NIST algorithms going through, and I think IBM's been involved in 2 of them and is actively involved in 2 of them, and then one of the others was done by an IBMer. So they've been at this for a while.
So as we're giving advice to CIOs, CTOs about infrastructure and protection around quantum, give me 3 things that they should probably pay attention to preparing for quantum, not just from a quantum chip perspective, but from infrastructure readiness. I'm putting you 3 on the spot.
Yeah, so I'll take the first one. I think thinking about quantum safe algorithms, get up to speed on what NIST is doing on those 4 algorithms that it's updating. I think it's thinking about encrypting data, knowing it's going to be able to be hacked. So it's a kind of harvest the data now, decrypt it later type approach that a lot of these nefarious actors are going to take. So just be thoughtful, get up to speed on those NIST algorithms, be starting to ask your vendors what they're doing around quantum safe encryption. That would be the first one.
Okay, so the anomaly detection becomes critical on the data side. And if you don't have anomaly detection going on in your not just the data protection side of this, which is where you recover from, but the primary storage, you're in trouble, potentially in trouble. So, I mean, we talked last week about maybe what the B of A issue was. Was that an attack that nobody's talking about? But that means that they're going to be going after, and they're going to be going after where the biggest ones are, which is the mainframe and the transaction areas. And that's so every mainframe needs to button down IBM. So they're bringing it out in the market. IBM needs to resolve the problems with the Z.
Mm-hmm. So and that's why they've been talking about. That's specifically where they've been talking about quantum safe encryption for the last 2 cycles of the box.
So primary storage has got to have anomaly detection. I'll use another time to talk about encryption because I had a great briefing from Broadcom about what they're going to be coming out with on some encryption stuff that's going to be going on. But I'll stop there.
And I would just say CIOs need to start creating a list of areas they have to remediate across their IT infrastructure. They need to know clearly where they need to quantum reinforce their encryption and reinforce their algorithms for quantum safety. And they need to get that list and then work it backwards based on technical debt, cost to benefit in terms of where the biggest bang for the buck is, and get started.
And I'll give a bonus one: processes. This is going to impact processes. Do I have the processes to do new algorithms and everything that you folks just mentioned? Let's move on the conversation to BMC. Steven, you're a big mainframe guy. Mainframes are big. You're a big mainframe guy, and you attended BMC's event. What went on there?
So they'd come out the week before their big conference announcing that they were going to split the business into 2. So I've been tracking BMC. I wrote a Forbes article mid last year. This is a roughly $3 billion software company, 40 years old as a startup, if you will, private equity owned by KKR. So they've announced that they're going to split the business into 2. One of these names is going to have to change, BMC and BMC Helix. That's just going to get confusing for people. But they announced the split. The mainframe and Control M business is going to go into the BMC business, and their IT service management and observability business is going to be the BMC Helix business. I think you took, for exactly the reasons of why you described, Keith, old BMC is a mainframe company. BMC is more than a mainframe company. It's about 40% of their revenue is mainframe related. But I think given their history and their past, they're seen as a mainframe company. So I see this a trajectory for KKR to be able to realize value from the business that they own, spin out that observability and AI ops business, and where it goes from there once they're separate businesses is going to be interesting. Then I was obviously out at their conference this week, recorded a lot of video with their team. I think the key takeaway there is AI. Lots of focus on agentic AI, rolling that out across their product portfolios, either from the observability perspective and the IT service management in the Helix portfolio, what they're doing in Control M with the scheduling and automation piece, and then also rolling out AI. Bring your own large language model to their AI assistants for the mainframe. It was a very on message on 2024 AI type announcement, and it was just on the mainframe. So I think, all the announcements and all the events I've been to this year, it was exactly on message with where they're going. Code assistance, code explanation, bringing large language models and natural language interfaces to operational tasks. You could have been sitting in a Dynatrace briefing. You could have been sitting in a, HashiCorp brief. You could have been sitting in any one of the industry vendors we all talk to. It wasn't very mainframe specific, which I think is a net and good news. So what's going on with BMC right now?
All right. And again, we have a lot of news to get to. So, Camberley, talk to us about some liquid cooling goodness.
I can mention the liquid. Well, let me go over to the Lenovo Tech World, because we were at Lenovo had a public event, and then they had a day and a half of analyst event. And YY, and I am not going to try to pronounce his name because I would insult him, I think. But YY, who is the CEO, kicked that off. And we had a plethora of executives that were, CEOs that were there on stage with him, and including Pat Gelsinger and the CEO from AMD that was there, and talking about the Intel AMD X86 group that's going to further the purpose of the X86 and its standards that are out there, which was really, really, really cool. But one of those things that was announced was some liquid cooling, the new Neptune device that is a vertically installed, server system that is pretty cool, and it's 100%, non-heat. I mean, it's just that you use standard power for this thing. So maybe you want to take that a little bit, Steve, because you were
liquid cooling's got cool this week. I wasn't on the show last week. I was coming back from HPE's AI Day. They took a bunch of us out to their facility in Wisconsin to talk to us about their direct fanless liquid cooling Cray systems and high-end AI and high-performance computing systems. This week we've had Supermicro make some announcements as well. Coolit has made some announcements. And then obviously there was the Lenovo announcements we're talking about. Ron Westfall and I have taken all these announcements and synthesized it into a analyst coverage that's going to be available on Future Intelligence for those subscribers. So, because there's a lot going on in this space, I think the key takeaways for me: you cannot run GPUs in a data center at scale and not worry about how you cool them. These things are power-hungry beasts. You're going to be pushing over 70 kilowatts in a rack. And once you get past 70 kilowatts, you're going to need to worry about how you cool it. And that's where you're going to need to be looking at liquid cooling options and different approaches. Is it liquid glycol? Is it water cooled? How do you do it? You then get into the physics and the sort of properties of glycol versus water, the connectors. These things obviously don't want to leak. Is it copper wiring? Is it plastic cables? There's a whole bunch of stuff going on in this space, but it all comes down to that if we're going to roll GPUs out at scale, we're going to have liquid cooling.
I've toured a lot of tier 2 data centers. In other words, data centers not run by the hyperscalers, and the new ones are designed to assume that entire building is going to consume water to cool it. It's very interesting.
And one of the things that was very clear with them presenting, they understand that we have new data centers that are being built and data centers that we have to retrofit. Yep. And so they're looking at ways to, and so they have just like we talk about, the stages of VMware or whatever, what you're going to do with VMware potentially. And they're talking about the same way of saying, okay, so I've got all this here and I need to accommodate for it. How do I do that? So they are rolling, strategies out for customers to be able to do whether or not it's air cooled or water cooled, or systems that are partially water cooled and partially air cooled, depending upon what, folks have. And this was really because I asked them a question about where is the break even on water cooling, figuring that it's a big, huge, massive data center because my old brain about big frames and everything else. And they said, no, they have a college that is setting up a GPU closet, essentially. It's not a data center. It's more or less like a closet that they're putting in liquid cooling in there.
Well, it was interesting. It was interesting to me that HPE and Lenovo both independently said 70 kilowatts per rack is the cutover point. Once you get past 70 kilowatts, you've got to go liquid cooling. Apparently, that's the break-even point.
Well, and there is the ROI that is there as well. I mean, one of the things they talked about with this, that they found, and they quoted, I don't know if it's public knowledge, but one of the and big movie theater folks, not theater designers, they have liquid cooling GPU environment. They can run it 40% faster. I mean, you think about what that means, because they're not burning the machine up. When we run hot, it burns up. So, I mean, not only are you saving on the cost of the energy, but if you can push those machines that much faster, wow.
And they'll last longer. You might get a couple more years out of them. So that's good.
Yeah, our colleague Guy Curry is at Open Compute Platform, their summit this week, which is I'm a little jealous. If I'm going to go anywhere and geek out, it's OCP, because you see hardware on the floor. They're talking not just 70-watt cabinets, which is a lot for a typical enterprise data center, but right now some of the hyperscalers have 250-watt, 500 kilowatt, and 500 kilowatt, and now they're talking about 1 megawatt racks. We're seeing the density get smaller and smaller, so we're not talking about floor space. Diane, I know you're old enough as me to remember when data centers, colos charged on the number of tiles that you took up. Now It's not about tiles at all, and they'll give you as much floor space as you want, and it's about power and power commitment. So this is something to continue to watch. Liquid cooling. How are you going to cool the stuff? How are you going to accommodate denser cabinets? I would love to see how this university is just running the physical power cabling structure to get to the closet to provide enough power safely, and then kind of the environmentals around having that much power and the fire risk that goes along with running that much power in a building not designed for it. Speaking about power and buildings not designed for it, nuclear has become in vogue again. We're looking at nuclear as the only clean option for providing all of the power needed for these 1 megawatt racks.
Yeah, and the two are absolutely related. We were on the right trajectory, I think, with ESG goals. The systems were becoming more efficient. We were drawing less power in the data center, and then NVIDIA starts putting GPUs in everybody's boxes, and we've gone completely back the other way and worse. So, specifically the hyperscalers, you look at the sort of 4 or 5 big companies that are buying GPUs at scale. It's the 3 hyperscalers, it's Meta and it's Tesla. They're probably hoovering up 80% plus of the GPUs that NVIDIA is selling right now. So those guys are just purely struggling with power supply. We saw small...
and they all have net zero commitments. I mean, CIOs are depending on their cloud providers to help them reach net zero. Now, the hyperscalers are having to spend way more on power than they ever expected. And so I think this is why nuclear is in the equation. Google just announced they're going to buy 6 to 7 micro nuclear reactors to power
SMRs.
Yeah,
small modular reactors. I mean, just the flip on nuclear, the speed at which it's happened. We've seen Microsoft working with a power company to recommission 3 Mile Island. We've got Google and AWS making announcements this week about looking to bring in small modular reactors. I think if this is a trend that's come from nowhere in the last 6 months, I think they dipped their toe in the water. Somebody broke, Microsoft kind of broke cover with this, with the 3 Mile Island announcement. And then everybody has jumped on this bandwagon because what they thought
they have to, or they're going to be paid the bad guys, and they're not going to be able to get their AI dividends. They're hoping that AI is going to really pay off for them, but if they're being forced to curtail it because of the massive amounts of energy and having to pull coal-fired plants, or that could be a serious problem. This heads it all off at the pass potentially. We'll see.
Yeah, I thought it was a few weeks ago, but it was actually back in March. Amazon actually bought a nuclear power plant from Townsend, and I think they're contracted to take 50% of the set 960 megawatt power. So this is a trend that we're going to continue to see. I'm sorry, I cut you off there, Camberley. You were about to mention something.
No, I was... what I'm looking from a geopolitical kind of situation, we've had, Japan has always continued to have nuclear. France is heavily, invested in nuclear. It's, and United States is kind of like, oh, it's evil. It's not, and I'm sorry, so not.
And Germany's out completely. Yep.
Yeah. And so,
yeah,
so it's all of a sudden, but we will have to deal with the deposits. So.
Yeah, we just can't create enough clean energy in other areas to accommodate this much power.
It's a little more nuanced than that as well, Keith. It's around the regularity of that production of, wind is great, but the wind doesn't blow at the same the same amount every day. Solar, it's sunny some days, it's not others. You need if you're running a data center, you need it consistently. So that's the other thing that nuclear brings to this equation. Just on the geopolitical piece, I've been looking into this a little bit. China is building 200 nuclear power plants.
Yeah, we aren't there. Battery storage technology isn't going to fix this problem. We have to be able to consistently maintain systems. Moving on the conversation, we hit on it earlier. AMD and Intel announced a new advisory group. X86 is X86, right? Well, not so much. If you've managed data centers, if you've managed any kind of IT infrastructure at scale, you know that AMD leaps Intel, Intel leaps AMD, and ideally you'd like to mix and match your providers and buy from both. The nuance is that, just taking a look at the Dell portfolio or the Lenovo portfolio, you'll see a box like the 9860. It's the big AI box that Dell has been, making hay off of. A little dorky nomenclature. The Dell ends the last number of their servers with O for Intel and 5 for AMD.
HP does the same.
They also do the same. And the number of options you have for O servers versus 5 servers is massive. Intel rules the roast when it comes to the number of SKUs that a customer can get from them based on Intel versus AMD, which means that you're going to end up, even if you're an AMD shop, if you want a 9860, it's going to be an Intel chip. And so if you want, you're big on AI and you want the biggest, baddest boxes that Dell presents, they're going to be Intel chip, and interoperability is a problem. If you've ever done VMware, being able to live migrate one VM to another requires it to be on the same processor. And this has created problems for enterprises as they refresh and buy from separate vendors. And the goal of this group is to normalize some of that stuff, is to be able for X86 to be X86. My question to you three is, will this impact Intel's ability to compete with AMD? Are they giving up the kind of ruling X86?
I mean, there's two ways to look at that. I think first off, it is an acknowledgement that AMD is not the noisy, small little competitor that it used to be 10 years ago. You could argue that they should have done this 10 years ago. It was interesting watching some of the RISC-V community kind of bemoaning this and saying, well, we've fixed this with RISC-V. That's that open source community that does all of what this x86 group is planning to do, and they've been doing it across multiple different chip providers. We chat to the guys at Sci-Fi, probably the biggest sort of chip designer and provider in that space, and some of their social posts this week were quite interesting. But it's certainly an interesting move by Intel to acknowledge AMD at this level. Argue it's good for the industry.
I think it's just going to push workloads up the stack in the container model, where you don't have that type of issue, and you have much more flexibility on where that workload can run. And so, virtualization is obviously not going away, but I think we're going to see it more, especially business workloads, be much more containerized to avoid any of the splintering or any of the issues around that.
So I don't play that much into the CPU environment, but my outside looking in, it seemed that this was a way to compete potentially against NVIDIA. And long game, we talk about the CPU or the x86 being a viable option for mid uses. And if, versus, having a partner or whatever, the competition that's going on and how much they're, driving the market right now. This is a way to catch up.
Yeah, I agree. Some of it is AI. Pat and Lisa mentioned in their interview with Pat and Dan that
which was an exclusive, by the way.
Which was an exclusive, by the way.
Very cool.
They mentioned the AI extensions, AMX and AMD's version, but I think a lot of this even goes down to the consumer level. All of these extensions are compatible, but at the software level, it matters. That interface, if we talking about CUDA and the competition to CUDA, it matters how you are able to extract and get to what Dion is talking about. That if I'm buying x86, I expect a consistent interface from a software perspective. And when I don't get that consistent interface, you're disrupting my operations. And now I'm going to look to a RISC-V group. I'm going to look to an ARM group who I may not necessarily get the performance and the price value, but I am going to have operational consistency. So I'm looking at this as a operational consistent play. All right, we're out of time. I think we could talk about all of these topics for a half an hour. And if you want to get more of the half an hour, subscribe to the podcast. Tell a friend. I like to say, you know what? If your grandmother isn't into tech, this is a great podcast for her to still not be into tech. Until next week, bye on behalf of all my friends.